All right, ladies and gentlemen, we move right into our next short keynote, Man-Machine Manufacturing, when robots are at work. Manufacturing has now evolved exponentially from the traditional methods to being completely automated. In this session, we focus on how Indian companies are innovating and what are the key factors that can accelerate digital transformation when compared with global companies who are at the edge of advanced manufacturing and Industry 4.0. Our speaker this afternoon, giving us a little more of an insight into this, is Sonali Kulkarni, President and CEO, Fanuc India. Sonali has held various roles with the company in Japan and India since 1998. Under her stewardship, Fanuc India sustains 80% market share in the factory automation space and is Fanuc's fastest growing subsidiary. She is a passionate nature lover and has spearheaded initiatives to make all Fanuc facilities environmentally friendly with zero pollution. Ladies and gentlemen, please extend a very warm welcome this afternoon to Sonali Kulkarni.
I get to hold one of these because I wear a sari. Good afternoon, ladies and gentlemen. It is such an honor to be here amongst you at the NASSCOM Summit, and I hope I do justice to this. I'm here to talk to you about the industrial Internet of Things and how it has been working out in the manufacturing space in real time. And forgive me, I almost never talk about my company in fora like this, but Fanuc being at the cutting edge, it would be injustice not to take some examples from there. And I would like to start with a video clip, just a short one, to give you an inkling into how the Fanuc factories are working today, the state-of-the-art factories, which are completely connected and are using advanced IIoT. Manju?
The automated lines use a great number of
this is our motor factory. It is the largest motor factory in the world. And there are about, in all, 4,000 robots working at our shop floor at the foot of Mount Fuji in Japan. And here you can see it is adding the cap to the motor. It's getting fastened by our small robots, etc. And Fanuc has about 150 employees in the shop floors, but we have about 4,000 robots working there. And we manufacture only in Japan, the second most expensive country in the world. But we have been doing connected factories long before IoT was even a word, let alone a buzzword. So it is in the 1980s that Fanuc came up with our first unmanned operation, a 24-hour unmanned operation factory. This was in the 1980s. And then by the 90s, we went up to 72 hours unmanned operation, which is basically a weekend. And finally, by 2006, we launched our 720-hour unmanned operation, which is a month. So this is the background of, but Fanuc had been doing it in-house in order to make the best products to serve the world, because we serve the manufacturers of the world. In 2016, we started with MT Link I. We launched Machine Tool Link I. We serve the machine tool industry, which is the crux of any manufacturing industry. And you may wish to know that Peenya in Bangalore is the headquarters of about, that manufacture up to 70% of India's machine tools. Any successful manufacturing country has a very strong machine tool industry. So we launched Machine Tool Link I in 2016, and this is a simple collection and display software. So at the bottom of this, you can see as a variety of machines, vertical machining centers, robots, PLCs, whatever, of various manufacturers, and the MT Link I collects and then displays it and posts it to the upper layer, which could be the ERP or whatever. And it is believed that India is not at the cutting edge of manufacturing, but I'm very pleased to say the MT Link I, India is, for Fanuc, the largest country wherein we have already installed and commissioned 2,000 licenses. Our chief customers being India's the fastest growing and the second largest two-wheeler manufacturer across its 4 plants. And soon India's #1 car company is going to be launching this. And I credit this not to us, but to the sheer talent, the software talent that exists in India, which allows Fanuc India to deploy this, which Fanuc Europe or Beijing or Korea, etc., have not been able to do as successfully. But going forward, Fanuc is going to be launching the FIELD system. FIELD is an acronym, which is Intelligent Edge Link and Drive System. And it is a platform which basically will enable Fanuc and the machine builders to give greater value to customers. And this graphic at the bottom, you can see again repeats the shop floor with various machines of various vintages, various manufacturers. And then at the top is the ERP or whatever. And in the intermediate space is what we call the FIELD system, which consists of hardware, which is made by Fanuc. And Fanuc stands for legendary reliability. So our CNC, for example, the average mean time between failure in India is 54 years. So the FIELD hardware manufactured by Fanuc will be IP67. It will be observant, which means it handles harsh industrial environment, dust, grease, impact, temperature, coolant splash, etc. And then there is also open source middleware, which is also open to be developed, and applications which can be added on. Coming to, this is just a comparison. The way the FIELD steps up against what the MT-Link is, it adds edge control and intelligence. So the processing happens at the field rather than at the cloud. So if you see this icon on the right-hand side, the shop floor is described as the edge from where we fetch data, and the cloud is where most processing happens in other solutions. But in the Fanuc field, what we describe, the middle part is what we describe as the fog, and is occupied by the field, the hardware and the software, wherein all critical processing is done in real time, close to the edge. And as you can see, basically it optimizes the cloud computing, and it is closest to the source of data. And the advantage that FIELD gives is that it overcomes limitations of bandwidth, etc. We have to accept the realities in manufacturing in India still, the internet speed, bandwidth, etc. And we also provide high processability and processing huge amounts of data. I believe it's 1 terabyte at present, and it will be enhanced. This has not yet been launched. This is going to be launched in April 2020. Now, most of the manufacturers, at least in India, in the Indian subcontinent, are from the micro, small, and medium enterprises. Of course, we also have Maruti Suzuki and Tata Motors, Hero Moto, etc., who make 1.4 million cars or 6.7 million motorcycles a year. But if, there are plenty of small shops with 20 machines, 30 machines, wherein they wish to leverage the best out, the best OEE from the equipment, the best production, and grow, and the bright plant managers. For that, we have arranged the FIELD solution, which is for the medium scale, which could be just the presence of a field-based pro hardware, and which addresses a single network switch and up to 30 machines at each place. We call them production devices. But this can be deployed across various plants. And the beauty is that it has horizontal communication. So if you take, say, a tier 1 vendor to Hero Moto, and supposing they make conrods, and plant 1 achieves conrods, say, if the target is 1,000 conrods a shift, but plant 1 if the targeted time for the conrod manufacture is 35 seconds, but plant 2 achieves it at 30 seconds, this allows us to capture what is it that plant 2 did better, and then replicate it in plant 1 without having to reinvent the wheel. And the large-scale system, of course, works off a rack server and affords the same advantages, but at a much, much larger scale. The main features of the field architecture, which I would like to highlight now, is you see all of these, the main purpose of these devices is to get the most efficiency out of a shop floor, but devices that monitor the other devices for efficiency are not being monitored at all. So for this, Fanuc has introduced what we call the Field System Manager. It is like a watchdog application, which helps figure out whether the field system is actually working or not and address it. We also have an open source online store wherein applications are developed and available for a small fee for anybody. They could be developed by machine builders, by experts, by Fanuc itself, etc. This again is to speed up adoption and efficient working. And it allows us to connect to all devices. It is not just Fanuc products, and nor is it machines of a certain vintage. We can connect even machines which were manufactured in 1980. The reason I mentioned this is because of our legendary reliability and lifetime service promise, we do have machines which are 30 or 40 years old out in the field, which are functioning very well. So the field system can talk to any one of these, and also has a handshake with protocols like OPC and the MT Connect of the US, etc. I mentioned the field applications. Recently, last week at GymTOF, which is one of the world's largest machine tool shows in Tokyo, Fanuc launched two of very powerful applications. One is the which addresses zero downtime, also known as the IZDT. And essentially, it is a predictive maintenance software. It allows you to ramp up manufacturing expecting high season or even prepare for a shutdown, as also to replace a fan motor or something as simple as that and prevent a bigger failure in the loss of time and so on. And also the PMA, the IPMA, that is essentially, it analyzes a lot of statistical data. So for example, in this earlier example which I took, if the target is 1,000 con rods a shift, and in a certain place, in a certain plant, 10 of the 1,000 con rods are not making it in the targeted time. This allows us to study the parameters, what came in the way, and fix those. So it's pretty powerful. And there is space for many more will be being developed and available as the field system is launched. The limitations of cloud computing in the manufacturing world, essentially, in the Indian manufacturing world with our indifferent internet and bandwidth, etc., will be the time taken to transmit the data to the cloud and then time taken to receive it after processing back to the shop floor in order to take timely decisions. And these two aspects of the total time taken are not in the control of the shop floor manager or anybody, actually. So it is to circumvent this that the field is designed and available, and that's what we call the fog computing. The field sits in the fog, in the intermediate layer between the edge and the cloud. And not only non-critical data, but also data which does not need to be presented to the various officers of the company using this from the cloud are not sent to the cloud, and all critical processes and will be done at the fog level itself and very quickly available to the plant manager to take corrective action or to take different action, and that is the advantage of fog computing, aside from it being very secure and no data loss and so on. And this is the overall picture of the field. It's a solar system here representing various field systems in operations and so on. And at the end of this, I would like to present to you a couple of videos. I will start with a video wherein we robotically inspect a part with 9 components for presence and placement. Manju. So LR Mate, let me tell you, is our fastest robot. It's the fastest in the world. Moves at 4 meters a second. I'm sorry, we're having some difficulty. So before invoking machine learning, artificial intelligence, we used to be able to achieve it at 5.2 seconds. This is those 9 components, which you can see, like the cap, the O-ring, the bolt, the QR code, and so on. But this checking is enhanced with ML and AI to 2.1 seconds, which is a saving of 60% cycle time. And this is like actually happening in our shop floors in Japan. And there is another video I think I can share wherein we have a small robot which sorts, over here it is using ML and AI to sort colored pills. And it is our fastest robot in terms of 120 picks per second. And it not only picks, but also counts them. And it realizes when a pill is missed. So this is one of the displays. By the way, on a lighter note, I would like to share Prime Minister Modi and Shinzo Abe, the Prime Minister of Japan, were at Fanuc last week. And they were very intrigued by this. So as you can see, the robot is sort of mixing them all up here. And then using its learning, it will take a picture and at a high speed pick the right colored pills into the right jar. And also the orange ones. And then while picking up the red ones, there's a little mistake and one of the pills skids off to the side, but because it's counting, the robot knows to take another picture and do this. And a final one, since all of us are so in love with, I can't take credit, but thank you. And the final video, very quickly, since people are so interested in smartphones, and you may find it hard to relate to Fanuc, but here we are taking a smartphone frame, completely manufactured and ready for shipping. It is being inspected for surface finish by what we call a collaborative robot. It is not our standard yellow robot, but it is a highly sensitive robot to work shoulder to shoulder with a human operator. And it is also invoking machine learning to detect flaws and accept or reject these frames. But it also has iterative learnings, and so its inspection become all the more refined. And whereas a human operator can easily do this up to 5, 10, 15, 20 frames, but to do this for 8 hours at the same degree of accuracy is impossible. And so that's what this robot is doing. And the reason this is slow, this is, by the way, the same LR-mate robot that you saw, but it is deliberately slowed down because it is of the collaborative robot class for safety. And so in closing, I would like to say that this is where we are with IoT. IIoT would be more accurate. And everything that you see around you, okay, your cell phone, the entire body, the lens, the light guide panel over which you can so beautifully scroll and look at pictures of your dogs or your wives or whatever, is made by equipment which is made by Fanuc. So Fanuc is a very low-profile company, but it has been using the power of, I don't know if that is the right word, but has been doing this in-house and now presenting it to our customers starting April 2020. Thank you, ladies and gentlemen.
Thank you very much indeed, Sonali, for that very interesting keynote. We have a small token of our appreciation on behalf of NASSCOM and our sponsors. Thank you so much for having accepted our invitation, for being here with us. Please give her a big round of applause once again. Thank you very much indeed.